Hello, and welcome to the TechHub.Training Excel Determining Cost Drivers with Regression Challenge Solution. This video solution includes using the Data Analysis Toolpack, regression analysis, and basic math and statistical formulas. With that, let's get started. First, I'll open the data with the production data for Parks production business. You can see that the data is all the same as in the file that you were given. The first step of the challenge was to just do a gut check on the rate that was given in cell L2. I've moved mine because I've added extra columns here, so it's an M2. But you can see that it's an even $1,000 here, and that's found by adding up all of the manufacturing overhead and dividing it by all of the headcount, which does give us an overall average rate for the first 500 production runs, but there were a couple other ways we could have done this. For example, I created this column which finds the overhead to headcount rate for each individual production run, and then over here I've taken the average of that rate, the median of that rate, and the mode, the most occurring of these rates here. And you can see that there's a little variation. So there are several different ways to calculate this rate, and so it's kind of up in the air whether or not 1,000 is even the correct number if we're using the headcount variable for this driver. For part 2, we need to run a regression to see just how reliable this headcount variable is in predicting manufacturing overhead. So to do that, for this video, I'm assuming that you've already installed and have the data analysis tool pack in your ribbon here. So you open the data analysis tool pack and then scroll down until you find regression, and then you press OK. Once this dialog box opens, we need to select our Y and X variables. I said in the instructions that the manufacturing overhead would be the Y range, and for the X range, that'll be the headcount. For a little more background context information on this, the Y range is the dependent variable, and the X range is the independent variable. The way to think about this, especially in a managerial context, is that the X variable is what should be changing the Y variable. This regression will test how much, in this case headcount, affects manufacturing overhead. Since we've selected the labels at the top of our data, we want to check this box. And then, like I said, we wanted to put this in a new worksheet. And I've already created the worksheets that I want, so instead of doing a new one, I'll put it here in the headcount manufacturing overhead one, and we'll just put it in here and replace that data. So there we go, a fresh new regression. And the questions asked to take a look at the R squared here in cell B5. That R squared is very, very low, which is a bad thing for R squared. This means that there's not really a relationship, no correlation between headcount and manufacturing overhead. This p-value in cell E18 is statistically significant, but it's really the combination of the two that you want. You want a reliable p-value, but also a predictive R-squared value. So that's part 2. And we're asked to do a regression on direct labor hours and the direct labor cost. I've already run that, but you do the same exact procedure as we just saw to run this regression. Here we can see that the p-value is 0, and if we try to show decimals here, it's 0 forever. Like, this thing is very, very, very statistically significant. And then here you can see the R-square value. It's a perfect 1.0. This means that these two variables are perfectly correlated with one another. That means that when direct labor hours changes, the cost of direct labor changes. And that makes a lot of sense in a business where wages are paid hourly, because the more someone works, the more the company is going to pay for that labor. So this makes sense. We kind of see the two extremes here, a perfect correlation and almost a non-existent correlation between headcount and manufacturing overhead, direct labors and direct labor cost, direct labor hours and direct labor cost. So then the next part of the challenge was to run at least one more regression to find a better driver for manufacturing overhead. And it turns out that best driver is machine hours and manufacturing overhead. Again, I've already performed this regression. This number is written in scientific notation. We change it to number, though. We see that the p-value is well beyond 0, and that the r-squared is 0.91, which is a very strong correlation. So we can see that machine hours is a much better predictor of manufacturing overhead than headcount was. And just for fun, I ran regressions on every other variable as well. The production run, which doesn't even make sense, and that's proven here by the p-value. That's just coincidence that the production run number goes up and manufacturing overhead is what it is. So those obviously aren't related. Direct labor and manufacturing overhead is a little less predictive than even headcount was. Direct materials, likewise. Direct labor hours, none of these were very predictive, especially when compared to machine hours. So that was part 4. For part 5, I asked for some additional analysis. What I did was I used the regression outputs to predict what the overhead should be. And specifically, I used cell B17 here from the machine hours and manufacturing overhead sheet, and cell B18. I'll go there and show you what those are. So B17 is here, the intercept coefficient. You can think of this as the fixed cost, that every production run has its own fixed cost, and that's represented by this number here. And then every machine hour has its own cost. We would consider these as variable costs. And so my formula takes this fixed portion plus the machine hours coefficient here times the number of machine hours to predict the overhead for each production run. And then over here, I've gone one step further and calculated the percentage difference. So I found the change between this and the actual overhead and divided it by the actual overhead to find just how different each of these predictions was. And there was a lot of variance in this, so there are definitely some outliers here, like -72, -71%, and then positive 100% and positive 85%. Those are definitely outliers. However, the bulk of the data was pretty tight around distribution, and I even included this chart here to kind of show that yes, there are outliers clear out here and clear over here, but the bulk of the data is here between -7% and positive 15%. So overall, we can see that even though this doesn't perfectly predict the manufacturing overhead, this is obviously a much better measure than than headcount. And that's this challenge. Great work.